Hello children, welcome to Akshara 8 Foundation. So today we are going to start the numericals of simple harmonic motion. Yesterday in the last class we have discussed all the concepts in all the synapses. So now we will start concept based questions. See the page number 114. First question. A particle moves in a circular path with uniform speed, its motion is. Okay. A particle moves in a circular path with uniform speed, then its motion is. Okay. So if a body is moving in a circular path, we have discussed simple harmonic motion with the reference circle. So the projection of the particle is a simple harmonic motion. Okay. If a body is moving in a circular path, the projection of the particle will be in simple harmonic motion. Okay, about the diameter, about its mean position, along the diameter, about its mean position. Okay, so now the answer is here. Simple harmonic motion. Simple harmonic motion. So now the second question is, among the following the correct statements are. Among the following the correct statements. A simple harmonic motion is necessarily periodic. A simple harmonic motion is necessarily rotatory. An oscillatory motion is necessarily periodic. A periodic motion is necessary oscillatory. Okay. So here simple harmonic motion is a necessarily periodic motion. So periodic motion is nothing but it repeats its motion in regular interval of time. So now if the simple harmonic motion, then it will be definitely it is a periodic motion. So the first option will come. And second one, simple harmonic motion is necessarily rotatory. Okay, simple harmonic motion is necessarily rotatory, and oscillatory motion is necessarily periodic motion. Okay, so a periodic motion is necessarily oscillator. So we have discussed in the last class all the periodic motions may be the oscillatory motion, but all the oscillatory motions may not be periodic there. Okay, periodic motion means the body has to be repeat its motion there. Okay, about its mean position or about a fixed point in regular interval of time. So that is called the periodic motion. Oscillatory motion means the body will be having the to and from motion about the mean position. Okay, so the answer is here. Simple harmonic motion is necessarily periodic motion. Okay, because it will be repeats its motion about the main position. So then it is a periodic motion. Okay, so next third one, the displacement of a particle in SHM is opposite with displacement of the particle. So the basic from the definition, simple harmonic motion is nothing but the acceleration of the particle. Acceleration of the particle. When the oscillatory motion can be simple harmonic motion, then so when the acceleration of the particle is directly proportional to the displacement and it is opposite to the direction of the displacement, then we can say that oscillatory motion is simple harmonic motion. So it is opposite to the acceleration. So then displacement is opposite to the acceleration, or acceleration is opposite to the opposite direction to the displacement. So here option 2, third one is option 2. Fourth one is given, a particle is executing SHM, then the graph of acceleration as a function of displacement is A. So we have discussed the equation of the simple harmonic motion. Okay, any particle is having the simple harmonic motion, then the displacement of the particle which is in simple harmonic motion, it can be written by the sine function. Okay, so y is equals to A sine omega t we have discussed, or x is equals to A cos omega t. Whenever the particle is vibrating along the y-axis, then we can say y is equals to A sine omega t, or if the particle is vibrating along the x-axis, then we can say x is equals to A cos omega t. So we can write here, it is a sine function. It is a sine function there. Okay. Fifth one, in SHM there is always a constant ratio between displacement of the body and its acceleration. So acceleration and the displacement. Okay. Displacement and the acceleration. We know that here acceleration is directly proportional to the minus of the displacement then. So if you take the ratio of these two, we'll get a constant there, okay. So then the ratio of displacement and the acceleration will be always constant. Option 2 will come there. Sixth one, a particle moves in a circular path with continuous increasing speed. Its motion is, okay. So a particle moves in a circular path with continuously increasing speed. Its motion is simple harmonic motion. So means the projection of the body will be have the simple harmonic motion there. The motion of torsional pendulum is simple harmonic motion. So increasing speed means we can say here periodic motion also will come there. So seventh one will come there. Periodic motion, oscillatory motion, angular, simple harmonic motion, all of these will come there. Seventh one is fourth option, all of these will come there. Eighth one, which of the following quantities are always negative in SHM there, okay. So first one is given there, F bar dot A bar. So F bar dot A bar is the negative of acceleration and force will be the positive direction. So we get here the dot product of these two will come there negative. So F bar and A bar, because A bar is minus omega square x. So minus will be there A bar dot B bar or F bar dot A bar. So we'll get a minus sign here. Even the acceleration and displacement also. So acceleration is a negative value, displacement will be the positive value. The dot product of these two will get a negative value, okay. So then 1 and 3 will come there. Next, if a hole is bored along the diameter of the earth and a stone is dropped into hole, then so if a hole is bored along the diameter of the earth and a particle, a body is dropped into it, the hole, the small bore, then the particle means it will act like a projection of the particle which is having the circular motion in a circular path. Then the center of about the center of the earth, if the particle is moving, if you consider there, then the projection of that particle will be moving, having the simple harmonic motion about the center along the diameter there. So then here if a ball is dropped into a small bore which is made there, so along the diameter of the earth, then the small ball will be having the simple harmonic motion. So as the example of a body having the circular path about a fixed point in a circular motion, then the projection of the particle, how it will be having the simple harmonic motion. In the same way, a ball has dropped in a small bore along the diameter of the earth, it will be have the simple harmonic motion, okay. Now the 10th one, the displacement of particle in SHM in one time period is displacement of a particle. So this one we see here. 10th one, 10th solution. Suppose to understand this, we'll take the example of simple pendulum. Okay, simple pendulum is nothing but a small metallic bob is suspended by a rigid support through a inextensible thread or a string there, okay. So now if one oscillation is nothing but, suppose it is having the pull horizontally towards left or right, then this will have the oscillations about this mean position. So two extreme positions it will be have there. So let us consider this extreme position 1 and extreme position 2. So if you consider from the mean position, this is to and fro and then coming to here then. So one complete to and fro motion is called one oscillation there, okay. Then so one extreme position, so here the displacement if you consider there, x is equals to a if you consider here, and it is started from where their initial position is, so mean position, initial position is mean position, and it will go to the right side, so right towards right extreme position, displacement will be a, and again it will become to the next extreme position, means that is a 2a, again it will becomes in one oscillation it will be stopped at the mean position there. So now the ending point and the starting point of the simple pendulum at the mean position, so it will be 0 there. So in one oscillation the displacement of the particle will be 0 because there is no difference between the initial and final position, so it is 0, okay. So therefore displacement d bar is equals to 0 in one oscillation of a simple pendulum. Okay, but here the distance will be there. Distance will be there. So in the next question, distance they ask there. The 11th question, distance. Distance we can write here total length of the path. That is nothing but this is A and here it is 2A and A. So means A total A again 2A and here 2A will come there. Okay. Towards first extreme position, maximum displacement is here A, and again it will be comes to the next extreme position, that is A plus A 2A will come. Already A 3A is completed there. Then in one oscillation we have to consider up to the mean position there. So there one more A will come there. Then total displacement, total length, so that is 4A will become there. So there the distance in one oscillation of a simple pendulum, distance in one oscillation of a simple pendulum is 4A. Okay, we can say here from M to E, so that here we can write there distance D is equals to, so ME1 plus, we can write here E1 E2 plus, so E2 M we can write there. So that means what happened here, this is A plus E1 to E2, that is here we can write there 2A plus again here it is A there. So therefore distance it will become there 4A. 4A will be the distance. Displacement will be 0. Next 12th one, number of oscillations in 1 second. Number of oscillations in 1 second. So that is called their frequency. The number of oscillations per second is called frequency. So now we are going to see here exercise problems. First question you see here. A particle moves in xy plane according to the equation r bar is equals to I cap plus j cap a sin omega t plus b cos omega t. Okay. Then the motion of the particle is, so here periodic SHM along a straight line, all of the above. So that equation r bar is equals to, in exercise problem first one, the equation is given here, that is in xy plane. So here we can write like this, y is equals to, displacement equation is given there, I cap plus j cap. So here it is, equation is given there, a sin omega t plus b cos omega t. Okay. So that equation will be represents the displacement equation. So we can compare this with the standard equation, y is equals to a sin of omega t. So we can convert this total equation into the single sine function. Okay, by taking a value is r cos theta and b value is r sin theta. Then we can convert this into the symbol in this form. So then we can compare there, and so that will become here a sin omega t I cap plus b sin omega t j cap we can add there. So that is a simply it is a total, that equation, above equation represents it is a simple harmonic motion. So displacement of the simple harmonic motion. Then we can say this is the, that means the particle will be having the simple harmonic motion there. Okay. So if it is a simple harmonic motion, it is a periodic motion also. Okay. Along a straight line, and all of the above is given there. So SHM and periodic along a straight line. So if it is given here in coordinate system along x-axis and y-axis, means it will be like this. We can represent that is along a straight line path. So then we can say here all of the above. So fourth option is right. All of the above we can represent there. So next question, the motion of a particle varies with time according to the relation y is equals to a sin omega t plus b cos omega t. Then, so here it is the second equation is also it is given by same like this equation. So here it is given there a sin omega t, small a sin omega t plus small b cos omega t. Yes. This equation also we can convert into the single sine function. So like if you take here a is equals to r cos omega t, okay, and b is equals to r we can write here like pi we can take here cos pi, and b is equals to r sin pi if we take r sin pi if we take, then that equation will become y is equals to r cos pi sin omega t plus r sin pi cos omega t. Okay, so we can write that equation now. If you write rearrange these terms there, so we'll get here r sin omega t cos pi plus r cos omega t. We can write here sin pi. So then if you take here r common, it will become sin of omega t plus pi. So that equation will be represents the standard equation y is equals to a sin omega t. So then therefore we can say that particle having the simple harmonic motion. Okay, the particle having the simple harmonic motion. Then what will be the here amplitude, resultant amplitude. So here we can represent that by using this one. Y is equals to here, if you take r common, we can write here sin of omega t plus pi, we can write here sin of omega t plus pi. So y is equals to r sin of omega t plus pi. But here what is the r here? R can be written as here. So if you write here r square and this equation here, r is nothing but what there? A is nothing but r cos pi and b is nothing but r sin pi there. So if you do squaring on both sides, if you do the squaring on both sides of these two equations, we will get r square is equals to r square sin square pi plus r square cos square pi will become. Okay. So if you do squaring on both sides, we will get here r square sin square pi, here r square cos square pi will get. So that is equals to, we will get here a square plus b square. Therefore here if you take r square common, okay, so then here sin square pi plus cos square pi we can write here, sin square pi plus cos square pi. So we can write here a square plus b square. So r square is equals to, this value is 1, okay, from trigonometric first identity it is 1 there. So that is equals to a square plus b square. Therefore here the resultant amplitude is square root of a square plus b square, square root of a square plus b square. That is the answer. So answer is here, fourth one we can add then. Fourth one is the right answer. So third one, two linear simple harmonic motions of equal amplitude and frequency are imposed on a particle along x and y axis respectively. The initial phase difference between them is pi by 2. The resultant path followed by the particle. There. Okay. So we can write here two linear simple harmonic motions of equal amplitudes of frequency are imposed on particle along x and y axis respectively. The initial phase difference between them is pi by 2. The resultant path followed by the particle is So here we can say that is the along x-axis and y-axis there. If it is along x-axis and y-axis, in the first question we have seen there, that is a straight line. So we can say here the answer is straight line path. Okay, answer is, we can say here, straight line path. and the phase difference between them is 90 degrees, it is given there. The phase difference between the 90 degrees means, so we can write like this. So phase difference between the two along x axis and y axis means this is 90 degrees, pi by 2, 90 degrees it is. Then if you draw a curve like this, then we'll get a circle. So we'll get here, it is the circle. The particle will be move equal amplitude and frequency. They have the equal amplitude and frequency. So equal amplitude and frequency means we can say that is a circle. Third one is circular path. Then the particle will having the circular motion. Then the projection of that, it will be have the simple harmonic motion. Now fourth one, the function sin square omega t. The function sin square omega t represents sin square omega t. So it cannot be represented by the standard the displacement of the particle having the simple harmonic motion like y is equals to sin omega t. Okay, we cannot represent this function, so it is not a periodic but not simple harmonic motion. It is not a simple harmonic motion. It may be the periodic. Okay, so but it is not a simple harmonic motion. That means it is not simple harmonic motion means acceleration of the particle is not equal to the, it is not directly proportional to the displacement, and it is not represents towards the direction is not opposite to the displacement. Okay, now fifth one you see here, if a particle is executing SHM with an amplitude A, the distance moved and the displacement of the body during its time period. So we have done already this one. So like here 11th and 12th question, 10th and 11th question, 10th and 11th question already we have done there. So distance and displacement, distance we got there 4a and displacement will be 0 there, second will come there. The equation of motion, so sixth one is given here. So equation of motion is given here, that is dp by, so dp by dt, dp by dt, sixth solution. dp by dt means the equation of motion of a particle is given by dp by dt plus m omega square y is equals to 0, y is equals to 0, where p is the momentum there. So this p is nothing but it is a momentum. So p is the momentum there. If it is a momentum there, if you send this that side, we can write like this, no, dp by dt, that is rate of change of momentum, is equals to minus omega m into omega square y, we can write now. Then dp by dt is nothing but what there. So according to from Newton's second law, from Newton's second law, f is equals to dp by dt, no, f is equals to dp by dt. So then here we can write there f is equals to minus m into omega square y, we can write there. Still here what can I write here, f is equals to m into a, also we can write, no, m into a. Okay, so from that equation if you substitute here, so m into a, it will become in place of f, if you write here m into a, we'll get here m into a is equals to minus m omega square y, it will become this and this will be cancelled, therefore a is equals to omega square y, a is equals to omega square y, we can write there. Okay, so that is the equation. So then if this is the equation here, minus omega square means it is the acceleration. So if it is the acceleration, then it will be having the simple harmonic motion. Okay, so that particle having the simple harmonic motion there. So eighth question you see here. Yes, eighth question you see, a particle moves on y-axis according to the equation y is equals to a plus b sin omega t. A plus b sin omega t, they are asking the amplitude here. So if you compare with the equation there, so generally y is equals to A sin omega t is given there. So A plus B sin omega t is given. So the amplitude of the equation we can write here B. B will be the amplitude there. Okay. So ninth one, a system executing SHM must possess. Okay. So inertia only, rest and restoring force only, both restoring force and inertia. So both we can say here restoring force and inertia we can add them. Due to the inertia, so because it is in the motion there, then again it will be comes to the motion, and even there is both restoring force also will be act there. So we can say there is a both restoring force and inertia we can write there. So 10th question is incomplete question. Now 11th one you see here, the frequency of a particle performing SHM is 12 hertz. Okay, frequency is given, its amplitude is 4 centimeters. So amplitude also is given there. If the initial displacement is 2 centimeters towards positive extreme position, its equation for displacement is, okay, its equation for displacement. So here the 11th question you see here. We'll write the data what they given in the question. So that is given there, frequency is given there F, that is 12 hertz is given, and amplitude A, amplitude is denoted by the letter A, that is a 4 centimeter is given. Okay, then the displacement of positive initial displacement we can write here x naught, that is a 2 centimeters is given there. This x naught is nothing but here t is equal to 0. At 0 seconds, the displacement, what is the displacement is there? That is the initial displacement there of a particle. Then we can write the equation of the displacement. Okay, so we can write the displacement equation we can write there. Okay, so generally we can write here y is equals to a sin omega t. No, y is equals to a sin omega t we can write there. Okay, so now if you write here, this is a x naught is given, so we can write here x now. So x naught is equals to a into sin omega t also we can write there. So initial position t is equal to 0. Okay, plus pi also we can write now, plus pi. A t is equal to 0. If you write here t is equal to 0, then this is a 2 centimeters and a is nothing but here 4 centimeter. This is a sine of omega t, omega into here 0 plus pi will become there, plus pi. So how much will become there? 2 by 4 is equals to sine of pi we can write, sine of pi. Means from this we can write here sine pi is equals to 1 by 2 we can write here. When it will be the 1 by 2? When it will be 1 by 2, sine of 30 degrees. Sine of 30 degrees means pi by 6. Pi by 6 now. Sine 30 is nothing but pi by 6. So therefore we'll get here pi value is sine pi by 6. Okay, then what can we write the equation now here? So equation we can write here x is equals to so x is equals to a value is how much there? 4 centimeters. Okay, if you convert that into meters, we can convert that into meter later. Then here sine of omega t, here omega value is given, and frequency is given there. So frequency 12 hertz. Then omega t is nothing but what can we write there? Omega is equals to 2 pi by t or 2 pi f we can write there. Okay, so then omega is equal to how much we get here? 2 pi into here 12 we can write 12. Then omega is equals to 24 pi. So then here omega t, generally we write the equation omega t plus pi. So omega value is 24 pi t plus pi value how much we got here? Pi by 6. Okay, so pi value is pi by 6. So therefore now if you convert this equation amplitude into centimeters, okay, this amplitude if you convert centimeters, then x is equals to 0.04 sine of 24 pi t plus pi by 6 will be the answer. Okay, so this is a final answer. This is the equation they asked there. So here they given frequency and amplitude at t is equal to 0. Initial displacement is given and they are asking the equation of displacement equation of the particle having the simple harmonic motion. Okay, so we should find out first the pi value initial phase we can find out there. So that we can find out by substituting it in place of t is equal to 0 in the basic equation there. By x naught is equal to a sin omega t. X naught is nothing but it is the initial displacement when t time is 0 seconds. Okay. Then here we should write here 2 seconds and amplitude is given here 4 centimeters. Then omega t, it is 0 omega into 0. So we'll get here 2 by 5, that is 1 by 2 is equal to sin pi. Then from that we'll get there pi value is pi by 6. So then if you write there all the equations there, and from this here from frequency we should find out the omega value, that we need to substitute in place of omega. Then we'll get the equation of displacement of a particle having the simple harmonic motion. Okay. Next question, 12th one. Amplitude of oscillation of a particle that executes SHM is 2 centimeters. Its displacement from its mean position in a time equal to 1 by 6th of its time period. Okay. So amplitude of oscillation of a particle having the simple harmonic motion is 2 centimeters is given there. Amplitude 2 centimeters is given. Its displacement from its mean position in a time interval in a time equal to 1 by 6th of time period. 1 by 6th of its time period there. So they are asking the displacement equation. Okay. We will see there 12th one. So amplitude is A is equals to 2 centimeters is given. A is equals to 2 centimeters. So time period, time is equals to means t is equals to it is given there 1 by 6th of its time period. So time period is denoted by capital T. That is t by 6th we can write there. T by 6th. So from displacement from its mean position in a time interval t is equals to in a time interval equal to 1 by 6th of its time period. So t by 6th. T by 6th. So we can write here x is equals to, or we can say y is equals to, x is equals to a sin omega t, a sin omega t plus pi, general equation, no? Omega t plus pi. Amplitude of oscillation of a particle that executes simple harmonic motion is 2 centimeters. Its displacement from its mean position in time equal to 1 by 6th of its time period. Okay. So we can write from this omega is equals to, okay, here amplitude is given, A is equals to 2 centimeters. So here 2 centimeters will come there, and x value we need to find out, and t value is how much is given there, 2 pi by t. So it is first particle, then no need to take this phase difference of that particle, then pi value means delta pi is equal to 0 we can take, then x is equals to a sin omega t, a sin omega t we can take there. It is the first particle. Okay, we are not comparing this with another particle having the phase angle there with this initial particle there. So first particle means we can take only here x is equals to a sin omega t. Okay, now x is equals to here a value is given there 2 centimeters, and sin of omega is nothing but 2 pi by t, no, 2 pi by t into here t is given there into t. Okay, into t. Now t value at what time they asked there? T by 6th time. Then x is equals to 2 into sin of, so 2 pi by t into t by 6. T by 6 we can add there. Now this t and t will be cancelled there. Therefore x is equals to 2 into sin of, so here 2 pi by 6. 2 pi by 6 means that is pi by 3. Pi by 3 means 180 by 3. So 180 by 3 means 60 will come there. So sin 60 value x is equals to 2 into sin 60. Sin 60, 180 by 3 there, okay. 180 by 3 means 60, no. The sin 60 value we need to write here. X is equals to 2 into sin 60 value root 3 by 2. So 2 and 2 will be cancelled, then x is equals to, how much we get there? Root 3. Root 3 centimeters. That is nothing but x is equals to, we will get here 1.732. 1.732. So this, therefore, approximately we can write here x is equals to 1.7 means approximately we can write here 2 centimeters. X is equals to 2 centimeters. Or directly it is given there in terms of root 3 only. So we can take this as the answer then. Root 3 centimeters. Next question, 13th one. The displacement of a particle executing SHM at any time t seconds. The displacement of a particle executing SHM at any time t seconds is x is equal to 0.01 sin omega pi t plus 0.05. Then its time period will be. So here the equation is given there. So equation is 13th question. Displacement equation is given, that is x is equals to 0.01 sine of 100 pi t plus 0.05 is given there. Okay, that is the equation. So if you write like this, x is equal to 0.01 sine of, we can multiply this term here, that can be 100 pi t plus, if the 100 multiply there, it will become 5 pi. Okay, 5 pi. So now compare this. So this value is, you compare with standard equation, a is equals to a sine of omega t plus pi. A sine of omega t plus pi. Okay. So if you compare here, this is the amplitude here and this will be the omega, and here this value will be the phase difference. So they are asking the time period. Time period means from omega will get omega is equals to 100 pi. So omega is nothing but what there? 2 pi by t. So then that is equals to 100 pi, we can write here 100 pi. So this pi and pi will be cancelled, and here it will be the 50. Okay, now from this t is equals to what can we write here? 1 by 50 we can write. 1 by 50 means 0.1 divided by 5. So we can write here 0.02 seconds. Therefore, the time period t is equals to 0.02 seconds. That is the answer. So 0.02 seconds. So 14th one is also same like this only. By using the equation and comparing the equation, then we can solve it there, resultant amplitude. So generally the resultant amplitude formula is from parallelogram law of vectors. No, for 14th one, for 14th question, I'll add the formula, you solve it there. Okay. So from parallelogram law vector, resultant vectors, no, from that we will get like this: a square plus b square plus here we can add there 2ab cos theta. 2ab cos theta, no, by using this formula. Okay, there are two amplitudes are given. Okay, a1 and a2 is given there, and phase angle is given there. Phase angle pi is given there. Pi is equals to how much there? 5 by 4. 5 by 4 means it is a 45 now. 45. Okay, if you substitute that equation, then we'll get the answer there. So here a is equals to a1 we can write here, and b is equals to here, that is a2 we can write and substitute, we'll get the answer. So 15th one is a particle start from HSM from mean position at t is equal to 0. If its time period capital T and amplitude a, then the distance travelled by the particle in time from 0 to t is equals to 5t by 4. Time period 5t by 4. Okay. So here total time period t. So the total time period, if you divide into 4 equal parts, it will become t by 4. So t by 4 is in t by 4 time period it will be travel. So one extreme position, it will be travel to a one extreme position there. So we can write here. Then the distance we can write here. Distance is equals to t is equals to 5 times of t by 4. 5 times of t by 4 means t by 4 is nothing but we can write here displacement of the particle we can write here a one maximum extreme position. Okay, from mean position to one extreme position is a we can write there. So then the distance is 0 to mean position to t is equals to 5t by 4 we can write there. So we can write here there is a 5a answer. Sixteenth one, the time period of oscillation of a particle in SHM is 4 seconds and its amplitude of vibration is 4 meters. The distance of the particle is 0.5 seconds after passing from the mean position. Okay, so they given here time period is given there 4 seconds and amplitude of the vibration is given there 4 meters. Then t, so small t is given there. Okay, so after passing from the mean position, means, so same formula we can take here, y is equals to a sin omega t. If you substitute all the equations, then we will get answer. Okay, try it there. Then 17th one, the period of particle in SHM is 8 seconds, means time period is given there. At t is equal to 0, it is at the mean position. The ratio of the distance travelled by it in first and second second. Okay, in first and second, we should find out the ratio. So capital T is given there, capital T is 8 second, capital T is 8 second there. So the mean 8 seconds means, capital T means what there, it is to complete one oscillation, 8 seconds there. Okay, so we can write there, it is 8 seconds, 17th one, 17th solution. So capital T is given there here 8 seconds. 8 seconds. If it divides this time period as divided by 4 equal parts, because from mean position to one extreme position, quarter part, and again from extreme position to mean position, same quarter part, then other side. So we can equate it 4 equal parts. Then if it has 4 equal parts means T1 is equals to, we can write here so 2 seconds. Okay, T1 is equal to 2 seconds. Then in the first term, means the body has traveled to first extreme position there. Okay, and the next it has given that the ratio of the distance travelled by it in first second and second second. Okay, first second and second. So first second means it is from mean position at zero time it is at the mean position. So in the first second it will be travel, it means here suppose the displacement here we can write there x is equals to a, one maximum amplitude we consider there, means so in t1 second, in 2 seconds it will be goes to a extreme position there. Okay, so if it is at extreme position, then if you write here t is equal to 2 seconds, then so if you compare with this equation, x is equals to a sine of omega t. Okay, so then here if you write x is equal to a, so a is equals to sine of here 2 omega, we can write 2 omega. Okay, means a. Then we will be get here, so 1 is equals to sine of 2 omega. Okay, then 1 here we can write there sine 90. Sine 90 is equals to sine 2 omega, we can write here. Then so 2 omega is equals to pi by 2, we can write here. Then omega is equals to pi by 4. Omega is equals to pi by 4. So here they are asking the distance travelled by means here omega is equals to, we'll get here. So time period 2 pi by t. Okay. So omega value we got here pi by 4. Then if you substitute in this equation there, x is equals to, so a sine of omega t. Omega is pi by 4 and t is here 2 seconds. Then we'll get pi by 2. Then x is equals to 2 means x is equal to a will get there. X is equal to a means that is a extreme position will get there. So now that means here x1 is equals to a we will be get there. Then in the second, okay, in the second. So in the second means, so we have to take there x2 means t2 is equals to, in second the time period will become here 4 seconds. Okay, we can take 4 seconds there. Then for 4 seconds, what it will be there here. So displacement travel it is, we can write here 2a, then a is equals to, here a is equals to 2a is equal to a into sine of omega t. Sine of omega t. Here omega is, this is 4 seconds there. Then again here this and this will be cancelled there. So 2 is equals to, here we can write there 2a is equals to sine of omega means 4 omega will get there. Okay. So from this, if you take the ratio, we'll get the answer. Okay. So now we'll see the numericals from the second synopsis. We see here now. So all the concept based questions you can solve there by using the conceptual bits. So fifth one you see here, fifth one, page number 126, synopsis 2. Synopsis 2, page number 126. Here fifth question is given there, fifth one. If the maximum acceleration of HHM is alpha, maximum velocity is beta there. Okay. So fifth one is the conceptual, it is not a conceptual, it is a numerical there. So they given here maximum velocity. So maximum velocity is given by here beta. It is denoted by beta there. And maximum acceleration, A maximum is given by, it is alpha. It is denoted by alpha there. Then they are asking the amplitude. What is the amplitude? A is equal to how much? A is equal to how much there? So we have the formula there. No? So V maximum what we got there? Maximum means A is equal to 0. No? A is equal to 0. So we'll get here A omega. So generally V formula is what there? A into square root of, omega into, this is omega into A square minus y square. A square minus y square. So at mean position, so y will be 0 there. If y is 0 there, what will become there? V is equals to A omega will get there. This is the maximum. Okay. So this one will get there. And A maximum what you got there? So we will take only the amplitude here. A square omega square. So omega square A. Okay, now they are asking the amplitude here. They are asking the amplitude. So now this is here, it can be written as, this is a beta. Na? So it is a beta and this will be the alpha, we can equate. Okay. So now from this, we need to find out here omega. Omega is equals to beta by A, we can write there, substitute in the second equation. If we substitute that is in the second equation, we can get here beta square by A square into A, we can write. So there is alpha here, then A and A will be gets cancelled. Therefore from this amplitude is equals to B square by A will get there. Amplitude is equals to B square by, alpha, this is alpha. This is alpha will get there, okay. So this is the answer. A is equals to beta square by alpha. So you send this A that side and bring this alpha left side, then it will becomes beta square by alpha will come there. Okay, that is the question. Sixth one, the phase difference between velocity and acceleration of simple harmonic oscillator. Okay, the phase difference between velocity and acceleration of simple harmonic oscillator there. So we will get it from by using this equation. A is equals to, so we got their acceleration formula. Acceleration, what we got there, minus a omega square sin omega t plus pi we got there. Okay, and here v, what we got there, v is equals to a omega cos omega t plus pi, cos omega t plus pi. Okay, cos omega t plus pi. So now here this is, if we convert this into cos function, okay, so what can we write here? If you want that into if you want this term into the cos function, we can write like this now: sine of 90 90 minus theta. Okay, so 90 minus of omega t plus pi we can write there, omega t plus pi. Okay, so here we can write the v is equals to a omega sine of, so omega pi by 2 minus omega t minus pi we can write there, minus pi. So here v is equals to a omega sine of so here we can write there pi by 2 minus pi minus omega t. Okay, now here the phase difference will become 90 degrees now. It is a 90 degrees. So this is a theta 1, you consider this is a theta 2. Then if you subtract, then we will get here pi by 2 will be the answer. Okay. So therefore delta pi, so delta pi is equals to pi by 2. Delta pi is equals to pi by 2. Let us consider this is a theta 2 and this will be the where it is, this is a theta 1. So now compare here. Okay, this is a theta 1 will consider there. Acceleration, no, they are asking with the acceleration. Okay, you don't consider your amplitude there, with the phase angle. So theta 2 minus theta 1 we consider there. So that will be cancelled here. Okay, then we'll get here it is the 90 degrees. It is a 90 degrees there. The phase difference between displacement and the acceleration, that is always opposite direction we have said there. If it is in opposite direction, then it is the 180 degrees we can write there. Okay. The phase of simple harmonic motion at t is equal to 0 is called their epoch. So epoch will be the answer there. Okay. So now mains problems we'll see here. Exercise first one. First question we see here. Okay, first question. First one. So displacement equation is given that the displacement of a particle executing SHM is given by x is equals to 0.1 sine of omega t 2 pi by capital T small t plus pi is given there, where all the quantities are in SI units. The time period of vibration is 3 seconds. At t is equal to 0 second, that a particle displaced by 0.05 meters. The initial phase they are asking there. So the given equation, so x is equals to 0.10 sine of 2 pi by capital T into small t plus pi is given there, plus pi. This is the equation is given. Then they said here all quantities are in SI unit and time period is given there. Time period t is equals to 3 seconds is given. Okay, and at t is equal to 0 seconds, the displacement x is given there, that is 0.05 meters. 0.05 meters. So now x is equal to t is equal to 0. If you substitute there, then we will be right here this value here, so that 0.05 that is 0.10 sine of here 2 pi by this time period is 3 is given, and here it is 0. Okay. So plus pi we can add there, plus pi. So what it will be happen there, here 0.05, that is 0.1 now. This value will become 0 and only pi, means here sin pi will be remain. Sin pi will be remain, sin pi. So then what can we write here now? So sin pi is equals to here 0.05 divided by 0.1 we can write. That means here 0.5 will be remain there. 0.5 will be remain. 0.5 is nothing but we can write here 1 by 2. When it will become 1 by 2, sine of 30 degrees. So therefore pi is equal, how much we get there? 30 degrees will get the answer. 30 degrees will be the answer. Second one we'll see. Second solution. So we'll read the question now. A body executing simple harmonic motion with an angular frequency 2 radian per second. The velocity of the body at 20 millimeters displacement when the amplitude of the motion is 60 millimeters is. Okay, we should find out the velocity of the body at 20 millimeter displacement when the amplitude is 60 millimeters is given there. So here, so given values we write here. Radian omega is given there, radian per second, means angular frequency or angular velocity is given, that is 2 radian per second. Okay, and next one it is given there. The velocity of the body at 2 millimeter displacement means x is equals to 2 millimeter displacement. What will be its velocity? So we should find out here velocity. Okay, and the amplitude of the body is given there. Amplitude of the body is 20. So 20 millimeters. Body, this is given there 20 millimeters. T is equal to 20 millimeters. What is the velocity? If the amplitude of the motion of the particle is given here, this is 60 millimeters. Okay. So velocity equation V is equals to, we can write here omega into square root of a square minus y square we can write here. Okay, or this only we can consider here y displacement at that and this one is given there. So here all are given. V is equals to 2 into, and these are, we should convert them into meters. We can convert, if we convert. Okay, so we'll let this value will be in the later we'll see there. Okay, then a value is 60 whole square minus 20 whole square we can write there. Okay, so V is equals to 2 into, then here so no need to convert there because answer also it will be in millimeters only will come there. Then 2 into, here we can write that this is 3600 and this is 400. 20 into 20. 20 into 20. 60 into 60. Okay. That's how much we get here now. So V is equals to 2 into, it is 3200 no? 3200 means how much we get there? 32. So V is equals to, we can write that is 1600 we can write now. 2 into 1600 means 16 means 40 will come out there. So 40 into root 2 we can write there. Into 2 is there. Okay. Then it is V is equals to 80 into root 2. 80 into root 2 millimeter per second. 80 into root 2 millimeter per second. Okay. Then here root 2 value how much? So V is equals to, if you write 80 into here 1.414. If you multiply this, how much we get there? Millimeter per second. Or we can write here, okay, multiply here. So if it is multiplied there, V is equal to 8 into 14.14 will come, 14.14. So here it is 32, then 8, 11, 32, 3, and here 12. 12. So 123.13, 123.16. So approximately it is equal to, so we can write here, it is V is equals to 120 millimeter per second. So 120 millimeter per second we can write that. Okay. Third question. Velocity at mean position of a particle executing SHM is V. The velocity of the particle at a distance equal to half of the amplitude is half of the amplitude. Okay. Half of the amplitude means, so here we should write there A is equals to A by 2 we can write there. So velocity at half of the amplitude. Okay. So general velocity equation what we got there, this one, no? Okay, we'll see this one. Third one. Third solution. So velocity equation V is equals to omega into A square minus Y square. A square minus Y square we can add there. A square minus Y square. So they are asking here the velocity of the particle performing simple harmonic motion when it passes through its mean position. Okay, sorry. Velocity at the mean position. Velocity at mean position of a particle executing SHM is V. So at mean position, that means here V is equal to 0, means here V maximum we can consider, that is a V is given there. Okay, V. And this is nothing but here A omega we can add there, A omega. Okay, so at mean position. Then they are asking here the velocity of the particle. So V2 we can write here when the amplitude is half of the amplitude. When it is, so what is this velocity at this one? When, so A is equals to, when A2 is equals to A by 2, half of its amplitude. A is equals to half of its amplitude. What is its velocity they are asking there? Okay. So half of the amplitude means what can write here? So here this one V2 is equals to, so V2 what can write here? V2 is equals to omega into half of the amplitude. A2 is equals to, then we can write this equation. So V is equals to A omega cos omega t. Cos omega t we can write there. A omega cos omega t we can write. Okay. So now from that equation, from this equation we can write here V is equals to omega into A square. So A square is equals to, we can write here, so A square by 2, A square by 2 whole square we can write, no, A square by 2 whole square minus Y square we can write there. This is V2. This is V2. So means in half of the amplitude, how much displacement the body has, that we need to find out there. Okay. So in half of the amplitude, how can you find out what the displacement of the particle we can write there? So that X is equals to, or Y is equals to A sin omega t we can write, A sin omega t. A sin omega t. So at t is equal to, they did not mention here what is at what time. Okay, it does not mention. At the mean position is given there, the velocity of the particle at a distance equal to, distance equal to half of the amplitude. So here it is not A, it is Y. Okay. So now simply we can write by using this equation. V is equals to A omega, this square root of, here omega only, this is not required. A square, this is A by 2, means here we can write there A square by 4 we can write. Okay. So then V is equals to here omega into, so square root of here 4A square minus A square divided by 4 we can write there. Okay. Then V is equals to here omega into here this one we can write there 3 root 3 A will come there divided by 2 will come there. So A omega is nothing but velocity V. So therefore here V2, so this is the V2 you can write here, V2 and V2. So V2 is equals to root 3 by 2 V, root 3 by 2 V, because here A omega is nothing but here V now, so that is the answer there, root 3 by 2 V. The velocity of a particle performing simple harmonic motion when it passes through its mean position is 0. Sorry, maximum. It is a maximum there. So at extreme position, velocity will be 0. At mean position, it has a maximum velocity. So fifth one, the displacement of oscillating particle is 0.05 meters. If its time period is 0.57 seconds, the velocity at the mean position and acceleration at the extreme position. Okay. Velocity at the mean position and acceleration at the extreme position. So maximum displacement is given there, maximum displacement 0.5 means here y is given there. Okay. This is the fifth one you write there, fifth solution. The given maximum displacement, that means here y amplitude simply directly it is given there. So y is equals to A, maximum displacement 0.05 meters, 0.05 meters is given there. Okay. That is a time period here. If the time period is 1.57, if the time period, the velocity at the mean position and acceleration at the extreme positions are. Okay. Velocity at the mean position we need to find out there. Here time period is given there 1.57 seconds, 1.57 seconds, and they are asking there maximum velocity, that is A omega, we can write there A omega. Okay, A omega. Then so A is nothing but here A, like that only we can write there. This one will be the 2 pi by t, 2 pi by t we can write there, 2 pi by t. Okay, now so here A value how much there, 0.05, this is a 2 into, this one we can write there 3.14 we can write divided by here 1.57, 1.57. Okay, 1.57. So this one we can cancel now. Here if it is multiplied with the 2 there, so we'll get this value, no? 2 1 join here, 2 2s will get there. So it will become 0.05 into 4. So if it is multiplied here, how much we get there? 5 4s are 20 will get there, means 0.2. So 0.2 meter per second, 0.2 meter per second there. Okay. So V maximum velocity will get here 0.2 seconds. In the same manner, we can find out here now acceleration, maximum acceleration. What is the maximum acceleration formula? A maximum is equals to here A omega square. A omega square we can write. So A value is given there 0.05, omega value. So it is 4 pi square divided by t square we can write then. Because it is omega square, no, this is omega value whole square. So we'll get here 0.05 into 4 and this is 3.14 whole square divided by 1.57 whole square. So here also these two will be cancelled and 2 will be remain there. So it will become here 0.05 into here 8, it will become there. If it is 8 there, means 0.4 will come there. So 0.4 meter per second square. Acceleration is 0. So this is a maximum square. That is the answer there. Okay. So fifth one is like this. Simply we should remember here this formula: maximum acceleration and maximum velocity formula. Okay. Here 2 to remain, no? Here, sorry, here 4 will come there. It is a 4 there. So this also, here 2 and 2 is 4 will come, no? 16. 16 5 is this is a 16, no? 16 will come there. So 16 5 is it is 8, no? Here 0.8 will come there. Not 0.4, 0.8, because here 3.14 divided by 1.5. So 2 will come there again here, 3.14 divided by 1.57. So it will be 4. 2 will be remain, 2 whole square is nothing but 4. 4 into 4, 16. 16 into 0.05. So 5 16 is 18. So 80 into here by 100 means 0.8 will come there. So 0.8 will be the answer. So option is here 0.2 and 0.8. This answer. So option 3 we can add there. The time period of a particle performing linear SHM is 12 seconds. The time taken by it make a displacement equal to half of its amplitude. Is half of its amplitude. The time taken by it to make a displacement equal to half of its amplitude is. So capital T is given there, 12 seconds. The time taken by it to make a displacement equal to half of its same formula we can use. So in the previous this question, what is they are asking the displacement here. Time taken by particle to complete half of its so time period is given there. T is equals to, so sixth one will do. Sixth question. So time period is 12 seconds is given there. Time period is 12 seconds. Then time taken by it to complete to make a displacement equal to half of its amplitude. Okay. Time taken by it to make a displacement means x is equals to, here are y is equals to what can I write here? Y is equals to here half of its amplitude. A is equals to this one, a by 2. Half of its amplitude. Then so 12 seconds. Time taken by it to complete. That means here displacement y is equals to, we can write here a sin omega t. A sin omega t we can write now, a sin omega t. So y value is given there. Y value is a by 2, means here we can write there a by 2 is equals to a sin of omega t. Sin of omega t we can write here. So a will be cancelled. So from this this 1 by 2 means sin 30 we can write here. Sin of omega t we can write here. Sin of omega t. So from this omega t is equals to, we can write here 30 degrees. Okay. So in radians we can write here, that is 2 pi by capital T small t is equals to, this is pi by 6 we can write pi by 6. Okay. Then pi and pi will be cancelled. So time period how much it is given there? This is 2 by capital T is 12 into T is given there. Then here 1 by 6. Then here also 1 by 6. So this it will be cancelled. Thus T is equals to 1 second. So therefore time period is, it will take 1 second. T is equals to 1 second. We will get T is equal to 1 second. So here seventh one, it is given their equation y is equals to 0.2 sine of 10 pi t plus 1.5 pi. So cos pi t plus 1.5 t. Then so if it is multiplied by 2 and divided by 2, we will get there so cos of 2 sin 2 theta So sine 2 theta is nothing but, we can write there sine of 0.4, sorry, 0.1 means y is equal to 0.1 sine of 2 pi t plus 1.5 t means 20 pi t plus 3 pi. 20 pi t plus 3 pi will come there. That is the equation there. Then it is a simple harmonic motion now. Time period here we can write there. Time period 2 pi by t. So omega is given here. Omega is given 10 pi. Then 2 pi by t means here. So 5 pi will get there. Pi will be cancelled there. So t is equals to. We see here this one. 7th one we'll see. It is completed. Okay. So now 7th one. 7th solution. 7th one is given here. Equation y is equal to 0.2 sine of 10 pi t plus 1.5 pi. 1.5 pi is given into cos of 10 pi t plus 1.5 pi. That is the equation. 1.5 pi. Okay. That is the equation is given. Then here, so y is equals to, if you multiply with 2 and, so divide by 2 and multiplied by 2. So it will be 0.2 sine of here 10 pi t plus 1.5 pi cos of 10 pi t plus 1.5 pi. Okay. So then here if it is multiplied there, this will be, this side here 0.1 will be remain 0.1. This is 0.1. If it is multiplied there 0.1 into sine of 2 times of this value. So 10 pi t plus 1.5 pi. 1.5 pi. Okay. If this 2 multiplies there, we will get here y is equals to 0.1 sine of 20 pi t plus 3 pi will get there. Okay. Now from this omega, okay, from this what they are asking here, they are asking the whether it is, if we got the equation in terms of y is equal to a plus b, y is equals to a sine omega t plus pi. So it is there in the standard equation. So it is, the particle will be in simple harmonic motion there. Okay. Then with time period, so what will be the time period we will get here? Time period means we should take here omega. Omega is nothing but this value, no? Then 20 pi we should consider. Okay, this omega is nothing but here 2 pi we can take, 2 pi by t. So this is a 20 pi. Then pi and pi will be cancelled here, 10 will be remain. So from this t is equal to 1 by 10 will be there. 1 by 10 is nothing but 0.1 second. So time period is 1 second. So here the option is here. So this equation, that particle will be in SHM with a time period of 0.1 second. It is the third option. Okay. So like this, we can, by using this standard equation, we can get an equation, velocity equation and axial equation. We have the problems there. So next, last synopsis we'll see here. So synopsis 3 is based on the energy equations. Okay. So concept based questions, you can solve it with the conceptual bits. Here the fourth question is here, page number 136, synopsis 3 will there. So synopsis 3, page number 136, fourth problem is there. Numerical problem will solve. Conceptual based questions you can solve it there. So linear harmonic oscillator has a total mechanical energy of 200 joules. Potential energy of it at mean position is 50 joules. Then maximum kinetic energy is, okay. So we know that total energy or mechanical energy is nothing but it is the sum of the potential energy and kinetic energy. Potential energy and kinetic energy. Okay. Then they given their mechanical energy and potential energy. So we should find out the kinetic energy. That's it. So how much they have given here? Mechanical energy is here. Mechanical energy is given there 200 joules, and potential energy is given here. How much? It is a 50 joules. Substitute there, and we'll get the kinetic energy there. This is 200 is equals to 50 plus kinetic energy. So kinetic energy value, how much it will become there? So kinetic energy is equals to 200 minus 50, we will get there 150 joules. So therefore, kinetic energy is equals to 150 joules. So kinetic energy equation is 150 joules. The value of displacement, fifth one is given there. The value of displacement when the kinetic and potential energies of simple harmonic oscillators are equal. So simply when, at what time, potential energy and at what displacement, okay. So it means at what amplitude, otherwise we can say here. So we should equate the potential energy and the kinetic energy equations. Okay, kinetic energy and potential energies of simple harmonic oscillators are equal. So when they are equal there, so what is here kinetic energy? Kinetic energy. So kinetic energy equation will be get here. Okay. So what is the kinetic energy equation we got there? So this is a fifth question. What is the kinetic energy equation we got there? Kinetic energy is equals to here half into m into v square. No, v square formula what we got there? That is omega square a square minus y square. No, whole square means a square minus y square will get there. Okay. And potential energy. So potential energy equation what we got there? Potential energy is equals to, we got the potential energy. So half into, that is, so half into k y square we got, no, k y square. So k is nothing but what there? Half into m into omega square. Okay, m into omega square we can write now. K is nothing but this one. So because here omega is equal to square root of omega square. Okay, k is equals to, yeah, if you equate there k by m, so m omega square we can write. This is a y square we can write there, y square. So now equate these two equations there. So potential energy equal to kinetic energy. Potential energy equal to kinetic energy. Equate these two equations there. What happens? Half into m into omega square. A square minus y square is equals to half into, so m into omega square y square. So now this half and half omega square will be cancelled. Then here a square minus y square is equals to y square it will become. Then if you send this y square that side, a square is equals to how much it will become there? 2y square. Then from this displacement we should write there. So it is a by root 2. A by root 2. So displacement is a by root 2. Displacement is a by root 2. A by root 2. This is the answer. Displacement is a by root 2. A by root 2 will be the answer. Simple pendulum hanging freely and it rests in vertical, because in that position kinetic energy will be maximum. Freely hang, it is hanging freely, rested vertically, means that is at mean position. At mean position kinetic energy is, it is, they said here rest. Rest means kinetic energy also 0. Okay, and potential energy also 0. It will become there. Generally, if it is oscillating. Okay, it is hanging freely and at rest in vertical position, because in that position, so kinetic energy will be 0 and potential energy also will be 0 there, because the height has to be taken from the mean position there. Okay. So by using that we can find out. Now we will see here exercise problem. Exercise problems there. Exercise problems 3. So linear harmonic oscillator has a force constant k is equals to 2 into 10 to the power of 6 Newton per meter and amplitude is 0.01 meter, has total mechanical energy. Then maximum kinetic energy they are asking there. Maximum kinetic energy. Maximum kinetic energy where it will be there? At the main position there. So maximum kinetic energy formula is what their first question, first solution. So they have given their k value, that is 2 into 10 to the power of 6 Newton meter. 2 into 10 to the power of 6 Newton per meter. And total mechanical energy, amplitude is given there. A is equals to 0.01 meters. 0.01 meters. And total mechanical energy, total kinetic energy is given there. Total mechanical energy 160. So total mechanical energy is 160 joules. Okay. Then they are asking maximum kinetic energy. Okay. So first we should find out this one, no? So this half into k x square. K, so k y square. K y square is nothing but here maximum, no? So half into k into a square we can write amplitude. Here half into k value, how much it is given there? 2 into 10 to the power of 6. A is how much it is given there? That is 10 to the power of minus 2. 10 to the power of minus 2 whole square means 10 to the power of minus 4 it will become there. So this 2 will be cancelled and potential energy will become here 100 joules. 100 joules, no? 10 to the power of 4, 10 to the power of 6 into 10 to the power of minus 4. 10 to the power of 2 will become, 10 to the power of 2 is nothing but 100 will be there. Then mechanical energy is what formula? Mechanical energy is equals to potential energy plus kinetic energy. So mechanical energy, how much it is given there? 160 is given there. And this how much we got there? 100 plus kinetic energy. What is the kinetic energy now here? From this, subtract then. If you subtract kinetic energy is equal to how much it will become there? 160 minus 100 will get there 60 joules. That is the answer. 60 joules will be the answer. A particle of mass 1 kg is executing HHM with an amplitude of 1 meter. The time period is pi seconds. Kinetic energy of the particle at that moment when the displacement is 0.8 meters from the mean position. Okay. So first we should find out here velocity by using the equation. No? So by using the equation is what there? Time period is pi seconds is given there, and the kinetic energy of the particle at that moment displacement is 0.8 meters. 0.8 meters. Okay. So velocity we should find out there. Displacement is given there, and so time period is given there. So amplitude is given there. Okay, amplitude. Then so velocity we can find out there. Velocity. Okay, third question you see here. Third one. In the second one, they are asking there in the above problem, the minimum potential energy. Minimum potential is how much there? It is 100 joules there. Okay. Then maximum kinetic energy is 60. Maximum kinetic energy. It is maximum at now third one, third solution. So in this question now, mass of the particle is given there, that is a 1 kg. 1 kg. So amplitude is 1 meter. A is 1 meter is given there. Amplitude is 1 meter and time period is pi seconds. Time period is pi seconds. Time period is pi seconds. Okay. Then the moment when the displacement is, the kinetic energy of the particle at the moment when the displacement is here means y is equal to 0.8 seconds. 0.8 meters. So what is its velocity? Okay. So from this equation we can write like this now, y is equals to a sin omega t, a sin omega t we can write there. So if you write there omega t, will get no time period 2 pi by t. V is equals to what can we write here? V is equals to here omega into here a square minus y square we can write there. At 0.8 second and amplitude is given there here. Time period, okay, that is given there, okay. Then here V is equal to how much you get there? So omega value we should find out here. So how to find out omega value? So omega value we can find out by using this equation. If you substitute here, it will be 0.8, that is equals to here 1, and sine of this we can write here 2 pi by t. Here this is a small t 1. So t value, this pi and pi will be cancelled here. Pi and pi will be cancelled there. 0.8 now. Omega value is 2 pi by t. Okay, directly omega value we can add there. It is 2 pi by. See me, that means here from this here 0.8 is equals to 1 sine of 2t we can add. So from this omega is equals to 2 we can add there. So if you write here v value, okay. So from this we can write here v is equals to omega value, how much you got there? This is a 2 here, 2 radian per second. So 2 into here a square value, how much there? 1 whole square, and y is equal to 0.8 whole square, 0.8 whole square. So v is equals to 2 into here 1 minus 0.8 means how much we get there? 0.64. 0.64 means v is equals to this total value we can add here. It's 2 into this one, how much we get there? It is 6, 10 will become 14. So 1.00 and 0.64. So we'll get here 6 and here 9. That means here 0.3. So that is here 0.36 will be remain there. That means here we'll get v is equals to 2 into here 6 divided by 10. So here 5, that is 6 by 5. 6 by 5 will be there, okay. Now the kinetic energy formula is what there? Half into kinetic energy K is equals to half into m into v square, no? Half into m into v square. Half into m value, how much here? 1. V value, how much we got there? 36 by 25. It is 36 by 25. 5 square whole square, no? It is, this will be 18. So simplify it, we will get the answer. That is nearly around 25, no? So 0.75 will get there. 0.75 joules there. Kinetic energy, it is 0.75 joules. 0.72. 0.72. 0.2. Cancel this one, we will get the answer there. Okay. So fourth one is given there, a particle of performing a linear SHM, its kinetic energy is 2 times of the potential energy a position at A, and its potential energy is 2 times the kinetic energy at another position B. The ratio of kinetic energy and potential energy. Okay. So ratio of potential energy and kinetic energy. So total energy will be, we should consider their equal. So at any point, according to the law of conservation of energy, total energy will be constant then. So at position A, potential energy plus kinetic energy, we should write there. So potential energy. So we can convert them into the, so at position A, 2 times the potential energy. So kinetic energy means K is equal to 2 times of potential energy at position A there. Means potential energy plus kinetic energy. So here we'll consider convert this potential energy, kinetic energy into potential energy, and at position B, kinetic energy, potential energy is 2 times of kinetic energy. So there you consider convert the kinetic energy into the potential energy. So then, if you simplify, you will get the answer there. For the fourth one, simple harmonic oscillator has amplitudes here 1:2 having the same total energy, the ratio of their frequencies, okay. So for the fifth one, we can add there uh, total energy equation we got there now. In the last class we have discussed it there, that is half into m into a square omega square, okay, half into m into a square omega square. So they have given the amplitude, ratios amplitude is given there for the constant having the same total energy. So E is constant, then their frequency. So frequency is omega square, no? So pi f1 square by f2 square will come there. Here it is 1 by 2 is given, 1 by 2. Then they are asking the ratios amplitude. So a1 a square by a1 square by a2 square, a1 square by a2 square there, okay. So a1 square by a2 square means, if we equate them, we will get the answer as here 1 is to 2. So for the fifth one, use this formula, we will get the answer. That is E is equals to total energy half into A into omega square into M. A square into M into, otherwise E is equals to half into M into A square omega square. A square omega square, okay. So the amplitudes are given there, A1 and A2 and omega 1, omega 2. Means F1 square by F2 square. So 1:4 will come. 1:2 only will come there because it is given there 1:2 and here also square is there. So it will become, it is 2:1 will get their answer, okay. So based on this formula only, all the problems are there, you can try them. A particle performs SHM on a straight line with time period capital T, amplitude is A. What is the average speed of the particle between two successive instants when the potential energy, kinetic energy becomes same? So they are asking here between two positions, same we can find out by the first this year. In the concept based questions we have done there, no fifth problem, same like a ninth problem. Okay, there we should find out here potential energy and average speed of the particle when they are two instants. Okay. So here we should find out the velocity there. So in the fifth problem we have found their y value, means displacement value we have found here, and here we need to find out the velocity. For that we have to equate their potential energy and kinetic energy equation, and we can get it there. Okay. So 10th problem is also same by simply their amplitude is given there and frequency is given, a is equal to t is equal to 0 seconds. Potential energy, kinetic energies are same there, then the displacement equation they are asking there, okay. So here we should find out by using the amplitude and frequency, we should find out here angular frequency, that is omega, we should find out and substitute the equation, we will get the answer there, okay. The total energy already we have done this problem there. 12th one, 11th one we have done. So 12th one is, so oscillates simple harmonically with the time period of 2 seconds. Time period is given. After what time its kinetic energy will become there? 75% of total energy. Okay. So we need to find out here the time. Small t we should find out there. So for that we have to, capital T is given there. Capital T is given 2 seconds. So small t we should find out there. Okay. So it is starting from, they have said their zero origin, means it is starting from origin, means it is starting from the mean position there. From that we should find out and equate 75% of its total energy. After what time will its kinetic energy 75% of its total energy? kinetic energy will become Ke, that is equals to 75, means 75 by 100 of mechanical energy. Mechanical energy is what there, same we will take there. From that we will get the so amplitude equation. So because kinetic energy formula is what there, a square minus half m omega square a square minus y square will get there. Mechanical energy is what there, half m square a square will get there. So from that y square value, that means y value will get, the displacement will get, and in the displacement equation you substitute there, we will get the time period, small t we can get. Y is equals to a sin omega t, and y value we get by solving this, by equating the kinetic energy and the total mechanical energy, 75% of the mechanical energy. From that we will get y value substitute in this equation, y is equals to a sin omega t. So from that we can get it there. Okay. So with this we have completed this simple harmonic motion. Okay. So then this volume 2 has completed all the chapters. If any doubts are there, we'll discuss later. Okay. Thank you children. Have a nice day.